Welcome. My name is Thomas Honig. I'm reporting to you at GTI Spindle Technology, where I am going to be doing a short tutorial on a new application on the App Store just a few days ago called SpindleScope. SpindleScope was written by a company named Faber Acoustical. They write a few applications on the App Store in regard to acoustical analysis, but this specific app is specifically tailored for vibration analysis. And what I'm going to be doing is I've got a picture up of my iPad on the screen so I can demonstrate and go over the different settings for SpindleScope. If you follow along how it can be used and how the settings work, and make this a full-fledged spectrum analysis application for the iPad. Okay, I'm going to open up the app, and as you can see, the app opens to a full spectrum screen, which you can see your frequency on the bottom, your amplitude on the left, and if you notice on the bottom, you'll see a list of the top 10 frequencies you would measure, from the highest amplitude being number 1 all the way down to 10, meaning the 10th highest amplitude. And at the very top you can also see that we have input 1, which is channel 1. We have 2 channels on this analyzer, but we're using 1 at the moment, and that number will equate to your overall measurement of that particular reading. Now let's go immediately right over to the left to the little gear setting option over there, and we'll pull that up to see what options are under that tab. Under that tab we have our sensor options, which will open that quickly, and you'll see we can use an internal or external accelerometer. The internal accelerometers are what come in your iPad that allow the screen to rotate to the proper orientation. They are very limited in vibration analysis, somewhat unuseful, or you wouldn't want to put your iPad on a rotating piece of equipment to measure vibration analysis. But what's more on that, you have a much more limited amount of frequency level on the internal accelerometer. So what we've done is we've developed our own special accelerometer for the iPad with, again, I mentioned 2 channels that we can actually run 2 accelerometers. We can run one axially and then one radially so that we can see shaft movements and things of that nature. Now if you notice below, you'll see the units. We can also measure in velocity, which is inches per second on the right. And if we toggle over, we can go to G's, which is measuring in acceleration to the left. So we cover both spectrums on that. And below that, you'll see your input channels. And if we tab on the input channels, you'll see there's channel 1 and channel 2. We can run both simultaneously, or we can just run one particular accelerometer at a time. And you'll see your calibration tab is below that, so that calibration can be done right from the iPad. But if we toggle back, you'll see to our original page there are also some spectrum analysis adjustments here. When we tab on that, that allows us to set our frequency resolution, which 1 hertz is the finest resolution we have, and it can go all the way up to 20k hertz. Okay, we'll tab back from there. We also have the data window. You have several data windows to choose from. We run in the Hanning window, which you see is checked off here, but you have other choices as well. Now below that, you'll notice we have our averaging. So, and you can see I have averages set here at 10-second intervals. So if we were to tab on peak, it would take a sample that would take 10 seconds long. You can see though I've got it tabbed on EXP, which stands for exponential. That would mean that it would be continually taking data as long as I've hit this play button to the left. It will continue taking vibration data until I hit the play pause button and stop it manually. Going back again, we also have our exported data server, where we can wirelessly transmit our data that we've collected on our iPad to either a PC or a Mac, as long as we're on the same network. And below that, you'll see the storage button for all of our PDFs that we would have collected in a route. And if you tap on those PDFs, you can see this is what the storage format looks like. And I'll quickly open one. It'll actually pull a past data that I took on a motor that you can see the cursor is landing on 3600 RPM. That was a 3600 RPM motor here at our shop just to sample this app. Now, if you notice also, there's a little envelope to the right. And what that envelope allows me to do is if I tap on that, I can open these PDFs in other applications such as air sharing, print, as well as another option, so that we can, on the new ISO 4.2.1, we can print directly from the iPad to a printer, which I'll get into why our background is in white at that point. If we click done, actually brings us out of our app, but if we relaunch the app, we'll go further into the settings panel. And you can see the little TV monitor at the top. This says no external screens are connected right now. If we wanted to look at that PDF I just pulled up and look at it on a big screen in a meeting to discuss a specific piece of equipment that needs maintenance or attention, we'll be able to put that on a projector or put that on a big screen TV so that we can have many people looking in at the data that we've collected. So that is also an option. Now next to that you'll see another settings panel. As I pull that up, this is our axis scales. We can vertical auto scale. We can auto scale so that our readings stay in the middle of the scale and on the application. We can also do lin or log on our vertical and horizontal axis. That's all preference. We normally run in linear mode so that it looks and appears like you see in the background now. Now below that we also have where we can toggle between Hertz and CPM. What that allows us to do is change the frequency domain on the bottom so that if you'd rather look at things in a Hertz format, you can, or CPM, which is cycles per minute, you can do that as well. Now below that you'll see I have harmonic cursors. I've got a number 2 in there. I'm going to demonstrate how that works a little further on, but that's the amount of cursors as you run your finger across the screen because of the touch interaction we have with this app. You'll be able to actually lay those harmonic cursors over the running speed to find multiples of running speed in these types of things. Now you'll see below that we also have a peak track on and off. I toggled it on, I'm going to toggle it back off. What that does, it would eliminate the harmonic cursors and it would take the cursor to the largest spike on the screen. So the peak track is basically what the words imply. It tracks to the largest peak on the screen. Now you see a button below there that also will toggle in our spectrum data on the bottom. If I turn it off, you'll see the graph carries all the way to the bottom of the screen, and if I toggle it back on, you'll simply see everything rise back up and our top 10 frequencies and our overall will be listed on the same page. Now the final and last toggle on the bottom here is to convert our scale to a nice blue, which is much more attractive when you're doing readings. But if you can imagine printing right from the iPad to a printer, the blue could consume a lot of ink. So we've made a toggle there to be able to put the background in white. And it's also a preference as well. So as we back out of that, we'll simply go to the little envelope at the top, which we all know in iOS means this is how we save our data. And you can see we've got 4 different selections of data that we can save in. We can save in a text file or a CSV file, and these files we implemented so that if you already have your own software and data collecting software at your plant or with whatever company you're working with, you can simply take these CSV and text standard files and take the data that you've collected with the iPad rather than the analyzer you currently use and dump that into the same software and have it work seamlessly. But for the iPad, you can see on the bottom we have Save Graph to PDF, and if you remember early in the tutorial I showed you how we can pull up those PDFs and actually open another applications such as air sharing. Also can be done in numbers and form your own specialty graphs. You can open those PDFs in a whole collaborative amount of other applications available on the App Store. We can also, at the bottom you see, we can save graph to photos, which is the simplest. If you tab that, it will immediately pull up a notes page, which it also does this in PDF mode as well. So you can input what machine number you're working on, what windmill you're measuring, whatever the article is you're measuring for later referral. You can put all those notes and information in, and it will attach it to the bottom of the saved image or the PDF document, depending on what you're saving it. We simply tap the save button after we put that documentation in, and shortly we'll get a little alert back that says image saved. The analyzer image has been saved to my photo album, and I know it's been saved. I could just tap OK. But now if we back out of the application here for a moment, I can go to the photos album where I have many different readings that I've already taken. We'll pull one up here real quickly by tapping, and of course we can screen in and screen out by sliding to different sample readings that we've taken. But you can notice this is a very good illustration of some bearing defects. To the very left, these small spikes are our running speed. One of them is our running speed. Another one is a multiple of running speed. But you can see we have an exceeding, out in the bearing frequency domain, large spike cluster, somewhere between 300,000 and 480,000 CPM. This tells us very clear that we have a bearing degradation problem going on that we can correct, and this is how we use the analysis. So now that this image has been saved, we can quickly tap on the side, hit the envelope from there, email the photo. It'll put it in the email format for us. We can simply type in a address and hit the send button. I will send this to myself, and hit the send button, and simply boom, the email has gone out, and now the reading is gone. Even before you leave the machine that you're measuring, you can email the readings from this analyzer. This is what makes the iPad such a special format for this. Being able to actually communicate data or go on the web and pull up graphs to compare data to is something that no other analyzer can do. But let's quickly go back out of the Photos tab and back into our application to make sure we've covered all the details. And again, we're going to quickly pull up back onto a blue screen here as well. Now, lastly, I just wanted to show is there is an information tab that goes back to the developer of this app, which is Faber Acoustical, as I mentioned earlier. And he's got many help pages. He also has a link directly to his website, and there are contact information there to be able to email back and forth any questions. But of course, I want to mention here also GTI Spindle Technology are the people that developed the hardware to make this whole thing come together. We've got our special accelerometers that work with the unit, as well as a full functional case and a transmitter that transmit from analog data coming from the accelerometer into digital format that the iPad can see. And that is all in a package that you can contact GTI Spindle on our website at www.gtispindle.com and get all the information and pricing you need for whatever your application is. Now, our price point does not exceed $4,000, including one full accelerometer. So as you can tell, that price point is far below anything on the market, and this is an analyzer that does far above anything on the market. So we hope your interest is high, but I hope this tutorial helps anybody that's already purchased the application and our hardware, how to run it. And again, if there's any other questions, please refer to the website, and I thank you for your time.